Hi guys, and welcome to another video. This video in particular is going to be focusing on arcs, sectors and segments. And what we're going to be doing in this video is actually trying to find out the lengths of different chords and trying to find areas of different sectors and segments and stuff like that, using our knowledge of trig and stuff like that, and actually applying exact values as well into it. So on the screen at the moment you can see I've got quite a few different terms and stuff like that. That's quite important. This picture is actually from the Sadler textbook. So if you are unsure about all the text and stuff like that, so I actually use the Sadler textbook. This is for Year 11 Math Methods in Western Australia. So that's the text I'm referring to if you're wondering. Let's have a good look here. So arcs just refer to a certain part of the circumference. So circumference, you should know, is the total perimeter of a circle. And the minor arc is just a small segment of it. A major arc is just basically the majority of it. Okay, and you can see that we commonly use A, B, and O. So O kind of means origin, and A and B are just 2 points on that arc, or on that circumference. So you can see that chord AB as well is just this one here. So this is just referring to 2 points on the circumference. So in this case A and B, and where it's connected just by a line, where it doesn't actually hit the arc on the outside. All right. We've got minor sector AOB, so when it goes to A, O, and B, so that makes a shape, and just that shaded area is the minor part. And then obviously you've got the same idea, A, O, and B, so still connecting, but it's just on the major outside part of it. A minor segment is where you get a chord that splits the area of a circle into two different parts. So the minor segment is just a smaller area, so this area here. And then the major segment is obviously just everything else apart from that small minor segment there. Just below here, I've just got a few different bits and pieces that are going to be quite important for the next few examples and videos I'm going to do on this series. So let's have a look. So I've got a circle here with my radius here. So you would note that any point from the origin, if this is O, any point from the origin to the circumference must be the radius, no matter where it is. So even if it's here, here, or wherever you go, they're all still the radius, and that's still R. Okay. I've also labeled the chord. So this is A and B. I've got a chord here. I've also got theta, or an angle. So for the most part, you will actually be given an angle, or you need to calculate an angle. I've also got the minor segment, which is in blue. So this is just sometimes you need to figure out what the minor segment is, and then the green you can see is the major segment. I've got here obviously some very important formulas in regards to the circle. We've got a circumference formula, which is 2 pi r. So I remember it, circumference being smaller, so it's just the outside. So I put the 2, and I think it's squared, but the 2's to the power, it's power of r. So or 2, sorry, r to the power of 2. I should correct myself, for the area, because it's a lot bigger, and r squared is a bigger number than 2 times r. Don't know if that made sense to you, but that's how I remember it. There we go. So that's the two formulas for area and circumference of a circle. Then I'm just going to skip this area of a triangle for a second, but I'm going to have a look here at this area of a sector and the circumference arc length here. So area of a sector is just referring to that major segment or minor segment, but instead it's just like the inside part. So I'm actually looking at, if I go grey, this part here, that's what I'm referring to as a sector, if that includes that minor segment on the top there. So a small part, so that's on the arc length, not on the chord. Okay, so that's when I use theta over 360, so whatever angle that sector is, timesing it by the area formula. Because think of it as a fraction or a small portion of the area of a circle, hence why it's a portion of 360, right? So arc length is a part of the circumference. So you've got your circumference formula here, and we're trying to find a small part of it, so theta over 360. Okay, lastly, I've got the area of a triangle formula. So this is important for when we're trying to find the area of the triangle. So this would be just that part here, so minus the minor segment, right? So that's the area of a triangle, which is our half AB sine C. So obviously it's like half times base times height, but when in any case we've got an angle, we use the sine formula of the area of a triangle. And because A and B, the two sides have to be inclusive, including and kind of like surrounding that theta. So because they're both r, I can just say it's r squared to sine theta as well. All right. So those are some basics, just a basic introduction on the arcs, areas, and segments and stuff like that. So tune into the next video to go through some examples. Thanks.